Greetings and welcome to video lecture 4.1. We're going to start talking about exponents, and in this full chapter series we're going to talk about exponents and polynomials. So we'll start off with exponents first. So here's a problem, and you might not think that this is very much money. Okay, so if you're given 1 penny on the first day of October, and then each day after that you're given twice the amount of money you received the day before, how much money would you receive on October 31st? Now, I don't mean how much overall money did you get that whole entire month. I mean just on October 31st. How much money would you receive? Well, let's break the problem down. On the first day, I get 1 penny. Another way of thinking about that is 2 to the 0. Why 2? Because I'm doubling things. Okay, 2 to the 0 is 1. Anything to the 0 power is 1. On day 2, I get 2 pennies. So that's 2 to the 1st. On day 3, I get 4 pennies, which is 2 squared. On the 4th day, I get 8 cents, woohoo, which is 2 cubed. On the 5th day, I get 16 cents. Okay, well that's 16 cents is definitely better than a penny. So let's keep going. On the 6th day, I get 32 cents. On the 7th day, I get 64 cents. And on the 8th day, woohoo, I broke $1. I get $1.28. On the 9th day, I get $2.56. On the 10th day, I get $5.12. Wow. This is starting to grow. Every day it's starting to grow. Now let's think about this. If on the 10th day it is 2 to the 9th, which is 512, and on the 8th day it's 2 to the 8th, and that's 256, what is it going to be on the 30th day of October? 2 to the 29th. That's a huge number. That is 5, 3, 6, 8, 7, 0, 9, 1, 2. And if it's in pennies, it's in cents. I move the decimal over 2. That is 5.3 million. And on the 31st day, 10,737,418 and 24 cents. All from starting with 1 penny. That's pretty amazing. Wow. Wow. 1 penny. So you can see exponents grow very rapidly. So starting off with penny, 2 to the 0, 30 times more, or I should say 30 renditions of it gets me to 10.7 million. Now you might want to try this on your boss. So go in there, say, hey, today I'll work for you for 1 penny. And tomorrow, if you double it, and the next day double it, and double it, and double it, we have a deal. And then by the 31st day of the month, he has to pay you $10.7 million. Now, I highly doubt that's going to happen, but it's worth a try, right? So let's start with multiplication of exponents. So if you recall, 5 squared is the shorthand of saying 5 times 5, which is 25. And 4 cubed is 4 times 4 times 4, which is 64. And negative 3 to the 4th, the negative is not included, so it is negative times 3 times 3 times 3 times 3, which is negative 81. If 2, the whole entire quantity, to the 5th is going to be negative 2 times negative 2 times negative 2 times negative 2 times negative 2, which is, there are 5 negatives, so that's odd number. Your result is negative. Negative 32. And a negative 3 over 4, 3/4, squared is going to be negative 3/4 times negative 3/4, which is 9/16. Now consider 7 to the 4th times 7 squared. Well, 7 to the 4th is 7 times 7 times 7 times 7. And 7 squared is 7 times 7. So isn't 7 to the 4th times 7 squared, the first one, 7 times 7 times 7 times 7, times 7 times 7. So isn't that a total of 7 times 7 times 7, 6 times, which is 7 to the 6th. Okay. So that leads us to our first property of exponents. If a is any real number and r and s are integers, then a to the r times a to the s is going to be a to the r plus s. When we multiply two expressions with the same base, we add the exponents and use the common base. So again, a to the r times a to the s equals a to the r plus s. So let's use our first property to simplify a couple of these problems. So 5 cubed times 5 to the 6th would be 5 cubed plus 6 to the 9th. What about x to the 7th times 8x to the 8th? Again, it's going to be x to the 7th plus 8. So our end result is x to the 15th. 3 to the 4th times 3 to the 8th times 3 to the 5th. Well, it's the same thing. We're going to use the same property. So it's going to be 3 to the 4th plus 8 times 3 to the 5th, which will lead us to 3 to the 12th times 3 to the 5th is 3 to the 17th. 5 cubed raised to the second power. Well, that would be 5 cubed times 5 cubed. But 5 cubed times 5 cubed leads us to our property 1 rule, so we can just add the exponents. So 5 cubed plus 3 is 5 to the 6th. Again, x squared to the 5th, but that's x squared plus x squared, x squared times x squared times x squared times x squared times x squared, which is going to be x to the 2 plus 2 plus 2 plus 2 power. Hope I said that 5 times. So it's x to the 10th. Our second property for exponents, if a is any real number and r and s are integers, then a to the r raised to the s power is going to be a to the r times s. In other words, a power raised to another power is the base raised to the product of the powers. So let's use our property 2 to simplify the following problems. So the first problem is a to the 5th raised to the 6th power. That would leave us 4 to the 5 times 6, which would give us 4 to the 30th. And x cubed raised to the 5th power will be x cubed times 5, x to the 15th. Let's consider 2x all raised to the cubed power, all raised to the 3rd power. I can write that as 2x times 2x times 2x. But with any multiplication, I can reorder it and I'm still valid. So I'm going to say that's 2 times 2 times 2 times x times x times x. But 2 times 2 times 2 is 2 cubed, and x times x times x is x cubed. And then I'm going to do the math for the 2th cubed, and that leaves me 8 times x cubed. So let's look at another problem. 4x squared y cubed, all cubed. So if I write it out, it's 4x squared y cubed times 4x squared y cubed times 4x squared y cubed. Again, I can say 4 times 4 times 4 times x squared times x squared times x squared times y cubed times y cubed times y cubed. In other words, 4 cubed times x squared cubed times y cubed cubed. And using our property 2, I can now say 4 cubed is 64. X squared cubed is x to the 6th. Remember, we multiply powers when we're raising a power to a power. And y cubed cubed is y to the 9th. So that gives us another property that we can use. Property 3 is if a and b are any real numbers and r is an integer, then when we raise the product of ab to a power, it is the product of the powers. In other words, ab raised to the r is a to the r times b to the r. The power of the product is the product of the powers. So let's use the 3 properties that we know to simplify the following expressions. So negative 1/4 x squared y cubed all raised to the 2nd power. That's going to be negative 1/4 squared x squared squared y cubed squared. Well, negative 1/4 times negative 1/4 is positive 1/16. X squared squared is going to be x to the 2 times 2, which is x to the 4th. And y cubed squared is going to be y to the 3 times 2, which is y to the 6th. Let's try another one. X to the 4th cubed times x squared to the 5th. That is going to be x to the 4 times 3, which is 12, times x squared to the 5th, which is 2 times 5, which is 10. So my final simplification is x to the 22nd. Third problem. Let's break this part into 2y cubed times 3y squared. So I'm going to give the cube to both the 2 and the y. 2 cubed y cubed times. Give the square to the 3 and the y. 3 squared y squared. So I have 2 cubed, which is 8. And I'm going to go ahead and do the 3 cubed because that's another number, times 9. And now I have y cubed times y squared. So that's y3 plus 2. So that gives me y to the 5th. Now I just have to say 8 times y is 72, y to the 5th. So why is it that we say squared and cube? Well, here's the reason. With geometry, we say squared is association to the area of a square. So A equals S squared, because it is a squared. And the cube is associated with the volume of a cube, which is a 3-dimensional square. So volume equals side cubed. So last little tidbit, scientific notation. So you probably have seen this a lot with over the years, where it's some number times 10 to the power of some number. And we call that scientific notation, but here's how we write it. N times 10 to the r power. But n has to be a number between 1 and 10. And r must be an integer. Let's try a couple of examples. So let's write 376,000 in scientific notation. What I want it to be is a number in between 1 and 10. So I'm going to have to move the decimal place over to between the 3 and the 7. So it looks like 3.76. But 3.76 times 10 to the what? I moved the decimal 1, 2, 3, 4, 5 spaces to the left. Therefore, it's going to be 3.76 times 10 to the 5th. If I want to write an expanded form given scientific notation, I have 4.52 times 10 to the 3rd power. So either I can say 4.52 times 1,000, which is 10 to the 3rd power, and I get 4,520, or I can use the decimal trick. But this time I'm going to move it 3 spots to the right. And if I need to add a 0 or 2 at the end, then that's what I do. So 1, 2, 3, and I end up with 4,520. So that's it for this lecture. So until next time, be seeing you.